Okay, so welcome everyone. Thank you for having me here. And my name is Tautvydas. I'm a senior QA engineer, approaching almost 10 years in the QA field. And I currently work at a company called Gritmind, so a few words about the company itself. We are a small company yet, but we are fast growing. We have a very high focus towards the AI stuff. And because of that, I actually have opportunity to be here and present you this framework that I built for one of our clients. So let's jump to the agenda for today. I will give a little bit of context on the actual application that we're testing. Then we'll see what challenges we're having and why we actually need testing. Then I'll show you the testing framework itself. I will show you how it looks like the workflow. And we'll cover a little bit about the agentic structure, what tools we're using, what tech stack. Then we'll cover the topic of why we chose to go custom instead of using something in the market. And finally, how we trust AI. So let's focus on the application itself that we're testing. So the application is all about autonomous vehicles. Our client is all about autonomous vehicles. It tries to cover a lot of markets, build vehicle fleets that work without human intervention. But as with everything, incidents happen. And when those incidents happen, the major problem is that there's no one to observe what actually happened. There's no human. So all they have from this incident is the logs. So what we get the logs from the vehicle itself, from the various system of the vehicle. Everything is put into the one zip file and basically given for the developer to analyze them. And this process is time consuming. It might take up to 3 weeks in some cases for the developer to actually find the root cause, find what needs to be changed. So you probably already see the problem, what we're trying to solve. We're trying to build an application that does this with AI and makes it much faster. So what we built an application, web application that has 3 stages. So first stage is triage stage. From that error report, we're just trying to see what the description is. Usually there's something a person writes in that error report, what happened, what we saw in the system that might have happened. Then we need to identify the vehicle, and finally the problem area. So it's like a high-level analysis of the incident. Then we deploy the sub-agents. I'll talk about them in a second, but their job is to investigate special parts of the vehicle, so basically subsystems of the vehicle. Then, when we have all the findings, and those sub-agents actually work in parallel, so the job is much faster when everything is done in parallel. And finally, we have a lot of findings that sub-agent has. We need lead detective. We call it lead detective, but it's another agent that just double-checks the findings and give us the final summary. So how the agentic structure looks like. So we have the main agent. Its responsibility is to do the triage. When the triage is done, that high-level effort is known, we invoke the sub-agent. So it's also a job for the main agent to invoke those sub-agents, and we have 8 of them. 7 of them focuses on the vehicle parts, vehicle subsystems, as you can see, and 1 is the lead detective that does the double-checking and like cleaning up the board of the findings. So now let's focus on why we need testing for this application. So first of all, frequent releases. So when we started working on the application, we started working with OpenCode. OpenCode was quite new when we started working. It's more popular now, but it has a lot of releases going from day to day. Also, we wanted to go more towards Microsoft stuff. So when the Copilot SDK came out, we get the email that, yo, okay, you can use the Copilot SDK to access the Copilot CLI in your applications. We jumped to that, but it was so fresh that it didn't have a lot of tools that OpenCode was offering. So we went back to OpenCode, and actually now we're using Agent SDK by Claude, which is probably the best for us. Another frequent release problem was the actual large language models themselves. So we started with Sonnet 4.5, now there's 4.7. As you can see, with each release of the LLM, you need to do testing once again to see if it still finds the problem of the root cause. So those are like frequent releases of all the parts of the system that we build it with. The next thing is the prompt improvements and updates. So we have those 9 agents and sub-agents, and each of them have their own prompts. And also, when we started building an application, we only had one main agent and nothing else. Those sub-agents came later, and it's still in progress. I mean, we only have the pilot ready, so it still might change in the future. But when you change the prompts, change the structure of the agents, it needs to be retested again to see if everything works. And finally, the custom tools. So each of those agents have their own tools. We build them custom to access the logs, to access the board where we keep the findings. Imagine it like a sticky board where the sticky notes are built by the sub-agents, and then the lead detective comes and just deletes them or manages them in some way. So all those things need to be tested when something changes. Another thing that we need testing for is the approach decision. So this differs from regular development. When the developers come, we have the architects that say, okay, this will be the tech stack for this application, and that's good. We're good to go. When we start building our agentic application, we don't know what is best for us. Basically, the solution is custom. We need to solve the custom problem, unique problem. And therefore, we need testing to identify if this solution works for us. So we started by identifying which LLM actually works best for us. For example, we tested Opus, Anthropic Opus versus Sonnet. And we're sticking it with Sonnet just because of the cost management. I will talk about it a little bit later about LLMs themselves. Then we have the number of agents. Already mentioned we have 9 of them, but we didn't know at first how many we needed. So we needed to test the approach. This works good for us. We're keeping that way, but yeah, it might change in the future and we need more testing. And finally, which looks a little bit off context here, data storing approach, but when it matters how we pass the data to the agents. So first of all, we tried using just zip, unzipping it and letting the agent do the reading. It didn't work out. Agent took a while to actually find something in the logs because it doesn't know the structure. It also went into the compaction very often because it was trying to read big files, and it was a mess. So we chose to go a little bit more into a database approach. So we're using DuckDB as for now, and we're using those Parquet files. So we parse the logs into those Parquet files, and then agent can check the structure, see how the structure looks of those files, and then queries work much faster in that way. So those custom tools are actually built to query those DuckDB Parquet files. And with that, actually, we save a lot of tokens. The time went down for the investigation, and so it's also a good approach for testing, that we're testing and seeing how data approach actually impacts our investigation time, tokens, and etc. So now let's see actually how our testing framework looks like. So everything lives in the GitHub Actions. We don't have a schedule or anything. We only run it on demand just to save the costs, because one investigation might cost from, I don't know, from $5 to 30. And yeah, for the client, it matters. So we only run it after some big changes, or when we know that something big changed, and just to make sure that we are good to go. So the first step is data preparation. So just open the browser, authenticate, and upload the error report and start the investigation. So we do that with the Playwright. Nothing fancy here. Old school approach, works fine. But when we start investigation, we actually invoke the main agent. I talked about the main agent already, but what I didn't talk is that we have it in a way that it has dialogue with the user. So it asks questions. So when it finds the vehicle ID, it double checks with the user if that is the correct vehicle ID. Also recommends sub-agents to invoke, so user can just accept the recommended settings or sub-agents, or add additional ones. And those questions need to be answered to have the final summary of our incident report. And for that, I implemented the Conversator agent, which uses Sonnet 4.6 LLM. But its job is pretty easy. Just to answer the questions, you usually just use the recommendations that sub-main agent gives. And also, its another job is to identify when the investigation is done. So the evaluator part can begin. For the evaluator, so we have 2 things that we're passing into the evaluator. From the main agent, we get the summary, which is basically the final message of the main agent. It gives full details on what happened during the investigation. And we have the board, so I already mentioned it's like a sticky board with the notes where all the subagents adds their findings. So it has even more information than the summary. So we take those two things, we pass it to the evaluator, and what the evaluator does, it compares those results to the ground truth. So we already heard the ground truth phrase today, and it's pretty much the same here. So we have the ground truth together with the error report that we get from the client. So the error report is actually the past incidents that we use for testing, and the ground truth is, we had it like in a description format where it's just a text on what actually happened, what was implemented, and what needs to be found from that error report. We put it in the JSON format for easier access like in the code. But it's basically a root cause that we need to find and all the findings that must be found by the main agent. So it evaluates and gives us the final evaluation. We have the scoring system, I'll talk about it in a second. Evaluation is stored in Azure storage, and from there we trigger the final report generation, and that generates us the HTML file, which is also fully made by us for the ease of use. It gets all the history data from the Azure storage with our current investigation. So that is the testing framework, but I want to focus a little bit more on the agentic part of this application, of this testing framework. So we have the user interface. The user can actually chat with the main agent, and everything works through the event stream. So the graph here might be a little bit off for some of you because event stream is only one way. I added both arrows because I'll talk about it in a second. But everything from the main agent goes to the user interface through the event stream, and how we know what main agent is doing, we're tracking the event stream. So we have two statuses, idle and busy. Those statuses actually don't come from the event stream itself. We are defining those statuses inside the orchestrator, but orchestrator is tracking like the tool calls, what agent is currently doing. So when you see that agent is asking a question, we actually have a tool call for that, and it's like ask question tool. So when you know that ask question tool is being called, agent is idle, waiting for the answer. And when the agent is working, so we know that it's busy. So those two statuses are being triggered like in the orchestrator with like a couple of ifs on those event stream events. So when we have the status, we need to call our conversator and evaluator. And both of those live in the OpenCode SDK. So since we moved to the Agent SDK by Claude, I didn't do that for our testing framework. I really liked OpenCode, and I will talk one more reason in a bit why I kept OpenCode. But OpenCode SDK gives us a lot of developer tools to basically just create a server inside our testing framework, use our own authentication of, for example, GitHub Copilot, and use our own premium request to call conversator or evaluator. So those are just MD files of the agents. And when we have the idle, we send the question for the conversator, get the answer, put it to the main agent through different API. And same happens when conversator says that the investigation is over. We send the response to orchestrator. Orchestrator takes board and summary from the main agent and pass it to the evaluator. So it's pretty simple on paper, a little bit more difficult in the code itself, but that's how it works. So now, when we know how it works, we can talk about why we chose for it to be custom. So first thing is the LLM limitation. This was more of a pain point when we only started working, since we only had GitHub Copilot, and GitHub Copilot doesn't have API. So we had to use providers that actually can authenticate with GitHub Copilot. So one of them was OpenCode. And since we moved from that in our actual application, I'm still with that on my testing framework. Just because of this reason, I still like to use my premium request, and they're much cheaper than the API tokens from the actual API key. The next thing is bare minimum approach. So I actually did a research on many market tools, and they offer a lot of metrics to track on, like when you're using LLM as a judge. I don't need those. I have my own ground truth, which are the findings that I need to find from the final investigation, from the final report. So if it doesn't find anything, it's wrong. If it finds more than it needs to, it's hallucinating. So basically the ground ground truth findings is everything that I need to track on. So that's why I chose to go this approach, only track what I need. And finally, the custom report, so we build it ourselves. It's in HTML format, really easy to share it with colleagues, with the client, and also change it if we need it. So here is like one line from our one other report, but what is happening here is it's only one incident here. We have a bunch of them, and what we're tracking, we have like a score which consists of 3 metrics, so mandatory, logs, and additional, and each of them has their own like weight. So mandatory is has the most weight, it's the most important, and it's like saying what you need to find, like in a text format. It needs to mention what was the actual root cause, and everything is written in that JSON file, basically in a text format. We allow paraphrasing for the LLMs, so it tracks if those findings were actually found as a mandatory findings. For the logs, it's pretty simple. When the vehicle crashes or something happens, error codes are logged in the logs, so those error codes need to be found. They lead to additional description of those error codes, and it's pretty simple. Additional is when the LLM actually rules something out. So for example, if the issue was in the brakes, and it says that steering was working perfectly fine, that's when we say, okay, that's a bonus point for you, but it doesn't fail investigation anyway. It's just an additional finding that it's nice to know. What else we track? We track the duration. So as you can see, it's about 15 minutes for a single investigation. And finally, the tokens. So it also matters for the cost. We can measure how much one investigation costs us. Like there's more detailed token view like in the whole report. It's not like one number. But for this presentation, I chose to use only one number. And finally, we have investigation model and evaluation model. So investigation is what the actual application is using, and evaluation model is what our testing framework is using. So when something changes, we know exact timestamp that the changes were made, and we can see if it was better or worse or something's more happened. But the main reason why we chose custom is that there's nothing in the market that can help us without actually making it custom. So that's where this slide title comes from, custom no matter what. So no matter what type of tool you take from the market, to make it work with your application, you need to make it custom. I displayed here a lot of things that would need to be added on top of any tool in the market to be able to process my application. So the data preparation, conversator agent, final evaluation, and ground truth, everything needs to be added on top of already market tools, and also the final report. So if you need to add custom metrics to already existing report, it becomes custom. So that's why I chose to not like evolve the market tool that I don't really know how it works, add more additional things on it, and have even bigger thing that I don't know how it works. I just use everything from, not from scratch. Scratch is a word, bad word here. I basically just taken a lot of things from the market and put them into one place to make my own custom framework. So now trusting AI. So we had this topic a little bit earlier today, and it's pretty similar in my case also. So to trust it, I need to test it and verify it. So I have 3 agents here in my testing framework. So first one is conversator. I don't have any test for it. I tested it manually. It works great. It never failed. That's enough for me to say that it's fine. And also, if it fails, nothing really bad happens. Just an investigation is over. It doesn't go to the conclusion. The scoring doesn't change. So the risk, it doesn't change any data that I'm interested in if it fails. But it hasn't failed since I moved to Sonnet 4.6. I tried to use GPT-5 Mini at first, and it was a mess. It didn't even know when the investigation was over. Maybe it was a prompt issue, I'm not sure. But when I moved to Sonnet 4.6, every issues were solved. Only thing that I have for this agent is some fail-safes. So I have the timeout. If it goes above 30 minutes, I'm calling it a quit. And finally, I have like a count for answers. I know that there should be only 3 answers in the investigation. If it goes above like 5, I'm also calling it an exit. So that's enough, at least for me in this case. The next elephant in the room is the main agent. So it's very non-deterministic, even though the input for it is pretty much always the same. We have the structure and the logs. Even if we put the same logs, the output is very non-deterministic, and it marks those findings in a different way, different nodes, and etc. And to test it manually, it's time consuming. So as you saw, it takes about 15 minutes for the investigation to run, and to manually verify it, it can take, for example, 30 minutes. If you need to do that 10 times a day, you can check what time it takes. And it also, if you need to trust it, you need to do a lot of testing on it to see if it actually works. So that's why we built the evaluator agent, which is much more deterministic, just because it takes input from the main agent, and the output of the evaluator agent is structurized. So we have a JSON which it needs to return, and that JSON can be parsed into the code, and we can test that JSON. So therefore, we need to test the evaluator in order to gain trust in main agent, because it's testing the main agent. And how the testing is done? Through the automation. So we isolate the main agent. We have the summary on the board. So just take an example that you take summary on the board from one of your top-notch investigations where you know that everything that needed to be found is found, and run it 50 times, 100 times through the evaluator, and you check the consistency. If it's good, very nice. You can add some negative scenarios where you pass different information from the ground truth and see if it fails. You can just remove parts of the summary on the board and see if it finds those gaps. So when we know that the evaluator agent is working as it needs to work, we can also trust the main agent. So that is actually the trusting part of our agent. We do not leave any just hanging out without verifying it. And now the summary, the final part of the presentation. So did it help us? Short answer is yes. The long answer is yes. So it actually found a lot of invalid tool calls in our investigation. So when the investigation is going and we see that some of the findings are missing that we should have found, we go in manually and check that part of the investigation, and we notice sometimes that the tool calls are failing and those findings are not added to the board. Therefore, agent doesn't see them. Also, incorrect findings. So when it finds something that it shouldn't, or it finds less than it should, we just go to the prompts and adjust them in a way so they can add more context to the prompts themselves. And this is like a continuous process. You add more testing data, you need to adjust prompts even more. And I mean, we have an issue with the client that we don't have a lot of testing data from their past, because we only need the testing data where they actually have the root cause, and the root cause is very precise. It shouldn't be like any, maybe it was that, maybe it was that. It needs to be precise. So that's the issue with the testing data. But we're trying to focus on every part of the vehicle subsystem to basically have the root cause in each of those subsystems of the vehicle. The next thing is basically determining which LM works the best for us. So as already mentioned, at first we're using Sonnet just because the cost and speed was good, and the accuracy was only a couple of points off from Opus. We might use Opus in the future when we put it to production for the clients to test, but as for now, we only have pilot for a couple of users from the client, so we're still doing it on Sonnet. Finally, we saved a lot of time for myself. So that hundreds of hours of manual testing went away. I can just click the pipeline and it gives us the results, and also the reporting part. So when client, team, or anything else asks what are the results, I just can pass that HTML file. I don't need to generate any Excel sheets or etc. So that was also very nice. And already covered the gaps in agent prompts. So key takeaway points. So actually, no matter what tools you're using from the market, it will always be custom, because custom apps require custom solutions, at least for the AI part. I'm not talking about casual end-to-end systems and end-to-end testing. It's much simpler than it sounds. So when I actually showed this presentation to colleagues, I mean, it is like the eye-opening experience that it isn't something rocket science. All the things that most people already know, just put into one thing and it does testing for you. So it's much simpler. And the last thing is, don't be afraid to go custom. With that, I have a motivational quote here that now we are more capable than we have ever been, just because we have all the tools, knowledge in the internet, the LLMs themselves, so we can build whenever we want. whatever we want. The only thing I want to mention here is try to go custom, but not from scratch. So you shouldn't invent the bike. You should just take the parts of the bike and put it in another vehicle that works for you. So in this case, that's what I'm doing. I'm not reinventing something from scratch. I'm just taking the tools in the market and putting them together to have something that works for us. And that was actually it for today. So thanks for your attention.
All right, fascinating talk.
Thank you.
I should say. There are questions.
Good.
Good. How do you validate that each LLM model is able to find the root cause after an upgrade?
So we actually have the ground truth file that I already mentioned. So when we have the upgrade, it's pretty simple to upgrade the LLM in the code and just run the test. We track everything in that error report, as you saw. So we know the point when the LLM was upgraded. And you just go and see what the findings are. So if it doesn't find anything, we know that something is wrong with the, not the LLM actually. LLM usually is okay, just something that how we communicate with the LLM. So the tool calls, the etc., things change when the version upgrades. So if everything works still the same, it finds the root cause and the score system is the same, consistency is great, so I know that it's working and it works for us.
Talking about ground truth, who created the ground truth and how often do you update it?
I won't go into the bushes or anything, but I took some ideas from other tools in the market. As I said, I'm not trying to reinvent something from scratch. I took some like those ground truth ideas from the prompt foo, from the deep eval, because those tools are like in the market, and I just added them to what I needed. So I took the structure of JSONs because they're also using, you can use the ground truth as a JSON. And I changed the structure of it. I added the things that I need to find it. And that's basically it. So you just don't try to go from scratch. Look into the market, look what other peoples are doing, and try to do it yourself. So that's probably
I would like to personally add a bit to that question, because ground truth is about data sets, composing data sets for your testing. So you are testing some kind of domain. So how do you know about coverage, that you are covering the domain, that you have enough variety of those ground truth data sets?
So it comes down to communicating with the client. So we don't know how their autonomous vehicles are working, like at first step. We had a lot of meetings with them, with like the most tech guys of their industry, and they gave us suggestions. So first we only had the main agent, then we implemented some of the sub-agents. We went into the meeting, presented them with those sub-agents of subsystems, and they said, okay, I see that there's a missing, for example, now in the previous meeting they said they're missing like a transmission agent. We still don't have that. We are like working to add it, but that's how it works. You go into the client, you check with them, and also the testing data comes from the client. So what they provide us, that's the only thing that we can take and test it on. So if there's nothing more to test on, we're never sure if there's like something that we're missing if we don't have the test date. So it's a little bit on the client, but on most part also on
basically
our shoulders.
You need to accept that you don't know what you don't know.
Yeah.
All
exactly.
right. How many % you trust the solution? Even if multiple bugs were found by it, have you noticed any real incorrect behavior of the overall solution?
I already mentioned like how the conversator wasn't able to like find when the conversation is over, but that was probably a part on me. Other than that, the whole solution, I would probably say I trust it 8 out of 10. I cannot say 10 out of 10, probably never. I will never trust AI fully. I need to verify it. But I mean, it's just time that makes the trust. So you test the solution, you see that it's actually finding the bugs and it doesn't find them like in the most ridiculous way. So when it finds the bug, I know that it's working. And with time, with more testing, it just gains trust from me.
So basically you are spending your 80% time on that 20% that it's incorrect.
I mean, I'm working on other projects in that time, but yeah.
All right, final question. What's your favorite cloud skill?
So Claude skill, we are actually not using skills. We are thinking about going into the skills. Now we have the sub-agents, so the sub-agents are actually different agents that have their own prompts. Skills is just the same agent that can get the skills from the MD file and basically just adds it on top. So I personally don't use a lot of Claude from the skill perspective. I am a GitHub Copilot guy. So from the skill perspective, I don't use a lot of it. One thing that I was able to use when I was creating this application, the testing framework, I actually was using open code, and I forgot how it works. But basically, it's an inbuilt solution with already inbuilt agents that help you build solutions. So they only ask you the questions, you answer them, and it builds the solution for you. So you only give them context. I probably can share it after the presentation if someone is interested. But yeah, I need to dig off my notes to remember that.
All right. Thank you for your answers. Thank you for your talk.